So we're going to be talking about basketball and race, which is my final project for AP Statistics. So first off, let's start off with the project plan, which is, what is my research question? Is there a racial difference in San Diego high school sports? Is one sport more played by a particular race than another? And the reason I chose this was because when I was a freshman and JV team basketball player, I was also the captain, and we won a couple of tournaments across San Diego County. And throughout these experiences, I really noticed that basketball is a sport that's known to be dominated by the Caucasian and African American descent. So I was the only Indian basketball player on my team, and one of the only people who I saw of my race, my descent. In almost all the tournaments, I haven't seen too many people like me. So I want to see the same relationship outcomes in other sports, or more than other sports. In this study, we're going to be talking specifically about other, like a more broad scale, because I know the tournaments I went to were pretty local, nothing too big. So I want to expand more to like California range. So next, project proposal. I'm not going to read all of this because obviously it's a lot, but my main idea was to get data from MaxPreps, which is a sports site that's run by CBS. I'm pretty sure that has a bunch of basketball statistics. I mean, they do everything, but basketball is specifically what I needed. And I actually didn't do what the project proposal had said, because I realized that using a chi-square test of chi-square test of independence would be a lot better from the results I needed than using t intervals and p values. So, I mean, I obviously did use p values, but not using t intervals. So, getting the data, I decided to go with the chi-square goodness of fit, and I do talk about that later. But I wanted to include what my initial inference was on what I would be doing, just to show how my process has changed. I thought I was going to carry out a survey of 20 to 30 athletes, but I just decided to do 5 to 6 different counties in California, because getting data was extremely hard for me, and I talk about that later. But yeah, finding data I thought would be a lot easier, but it was not. But yeah, I used Google Sheets. Like I said, I used TI-84 Calc. My calculator came really helpful when it came down to using the matrices to use the chi-square test to find the chi-square value, find the probability, find the degrees of freedom. And I used some Google Docs to type everything up. And I'm going to use everything I've learned so far, specifically the chi-square test in this case, to come up with an answer for this question. So I just want to talk about some modifications I have, which I've brought up before, but mainly, like I said, by doing more research, I decided that it would be better if I expanded my sample proportion to the entire state of California instead of just San Diego. And this was purely because it was just too hard to just find data just for San Diego. Even for California, I was only able to get data from the top 5 more populated counties in the state. So just getting it from San Diego just required a lot more time and a lot more resources that I just didn't have at the moment. And you can clearly see that my research question has been modified over and over again, because every time I find new data, I want to tailor it to that so that I can answer a question that's reliable to the source. And I mean, obviously, the topic hasn't changed too much. The questions are just barely getting modified, so not too many big changes, but the modifications are there just to, because going into the project, I had big expectations. I was going to get data, because I thought I could get data from anywhere. I thought I could get data from MaxPress, CBS, and I definitely should have done more research and gone onto the websites and dug a little deeper and found out that that data is not available for me. But besides that, I was luckily to get some information about the statistics I need, and that's why my question changed and modifications changed. And then again, I included everything, such as my initial inferences, initial plans, proposals, just to show you how my project has changed, or how my view of my project has changed. So bias. So how am I going to avoid bias? And to avoid bias, I'm just taking some measures to make sure that I get the racial diversity of schools that matches California racial diversity. So, like, for example, I'm not going to choose a school where it's predominantly white and they have like their school population or school demographics is 90% white and like 10% every other race in the school. Um, I just feel like that wouldn't be good. That would be really biased, especially if that's like one of the biggest schools we're taking. So I just wanted to break it down into get more diverse schools. So that's why sticking with the biggest counties in California most likely will bring me the diversity that I need. Um, and yeah, and I have it the diverse racial diversity in California just to show you. So 39% Latino, 37% white, 15% Asian, 6% Black, and 4% other. And this doesn't really matter to my research project like specifically when it comes down to the mathematical side of it, but it's just there to show you the diversity, and because that's the topic that we're going over. Now I needed to use accounts from different counties across California, the top 5 biggest counties, to find the chi-square value, which I talk about now. And we can use it, the chi-square test of independence, to find if there's an association between the two variables. And the null hypothesis is there is no association between race and playing frequency. And the alternate hypothesis is there is an association between race and playing frequency. Playing frequency just, I don't know how else to word it in a concise amount of words, but playing frequency just, it all means that, like, how many white players you see, how many black people players you see, how many Asian players you see, how many Hispanic players you see. It's just that counts the amount of players. Conditions. So the conditions, since we're doing a chi-square, we have to test for the counts, make sure they're in the counted data. And they were in counts. They were in percentages. Like I said before, I was able to get counts. So that was satisfied, and I was able to put it in a two-way table, so you can, that there's categorical variables that I've used. The data is independent because um, the amount of white players isn't affected by the amount of black players in the team. It's going to be random, and going on to that, the randomness is something that is also satisfied, and the expected value is at least 5 in all of the cells, so the expected value condition is met too. And so all the conditions are met, I decided to proceed. So here's some data I got. The first one is obviously the observed, and the second one is the expected. And I just calculated the expected by doing the total divided by the maximum total times the total. I said that wrong, sorry. So for example, for the white in LA County, I did 227 divided by 726 times 67. So it's that process I repeated for all the columns, and I was able to get the expected values, which is what we need to do the chi-square test for. And yeah, so you can see on the top, I have the 5 biggest counties: LA County, San Diego County, Orange County, Riverside County, San Bernardino. And then on the bottom, I have white, Hispanic, Asian, Black, and other races. And then I was just able to get the observed and expected data that I needed to proceed. And here's more of the data that I needed. Obviously, I like doing it like this because I can just take the sum of the observed minus expected to the square divided by the expected. And I was able to get a huge chi-squared value of 36.51. My calculator actually said 39.5, but I decided that since it was so high, it didn't really matter what it was. The probability was still going to be 0.001 or like extremely low. So the degree of freedom was 16 because, as you can see, there is and if you go back to the previous slide, there are five rows, 5 columns, and you can just do 5 minus 1 times 5 minus 1, which is 16 degrees of freedom. And yeah, so in conclusion, given that the p-value is so low and the chi-square value is so high, we have to reject the null hypothesis and conclude that there is an association between basketball team racial makeup and location in California, which is just saying that basically that one race is more probable to play basketball than the other, which is in this case white. And with this, we have to conclude that there is an association between race and the number of people who play basketball in California. So here's a journal article I wrote, and it's basically saying, do white students play more basketball than their other racial counterparts? Does one race play more basketball than all other in the state of California? In this study, we're going to analyze the results of a retrospective study where we analyze the answers to the questions listed above. First, we need to take the racial demographic of California, and we can find the 5 most populated counties in the state and analyze the number of basketball players in each one to find if there is an association. Now, after we have the results of the trial, we can easily conclude that there is definitely an association between basketball and racial presence in the sport, as white players are far more prominent than the others when it comes down to the sheer number of players in the game. This study shows us how prevalent each race of people are in California's high school basketball. But now we're just going to talk about the obstacles and challenges, which I have talked about before in this presentation. Biggest obstacle is clearly finding the data. Getting the data was extremely hard for me. I thought this data would be a lot more widespread and a lot more available, but it wasn't. It was just really hard to find. And I was altering my question to be able to answer the question, and I didn't. I'm thankful I didn't have to alter too much. I was able to come across a lucky some lucky data set that had everything I needed from the what's it called, CSF. And here are some extensions. I mean, obviously the biggest extensions I could do is just expand. I only did California. I could move on to um, the western states. I can move on to the eastern states. I can do America as a whole. I can do North America. I can do the world. I think just expanding by geographical presence is something that the best thing to do for extensions. And to conclude, I would just like to thank you for all your help during this course. And this project was definitely fun. And this experience during COVID was a different one, but it was definitely something that I enjoyed. And I hope you stay safe, and I hope to maybe see you around one day. I heard that when we first contacted, you said you taught at San Diego, which is in Encinitas, I believe. So I probably run into you sometime this day. I go to San Marcos High School. But yeah, thank you.